Hello, my name is Sumesh Shukla, and in this particular video, I'll be helping you with all the basics that you need to start your journey with the library Pandas. But before we start this video, don't forget to check out Scalar's free masterclass on Scalar's event page by industry leading experts. The link is in the description box. In this particular video, first of all, we will start with Python basics and then we will proceed with Pandas basics. But before we start, don't forget to subscribe to our Scalars YouTube channel. So let's start understanding about how we can work with Python. Now, if we talk about any programming language, we have to first of all understand some basics, like what exactly is data, what are the various data types, how we can hold that data, and then processing comes into picture. So we will first of all understand the basic, and then we will be talking about how we can write simple program in Python, followed by next thing is Pandas. So how to basically start with Python. Let me write down some raw data. 1, 2, 3, 4, 5, 6, 2.7, 3.6, 4.9, 5.8, 2.88, then Sumit Shukla data, then scientist, and then we have, let's say, true, false, true, false. Now all together, this all together we can call this thing as data. This is basically my raw data, or maybe information. Now each information over here, or maybe each data point over here, belongs to a certain type. So here, the very first series of data belongs to the type known as integer. And in Python, we call them as int, or maybe represent them as int. Then we have floating point numbers. So these are my decimal numbers, floating. And we call them as float in Python. Then we have a string. Now these are my textual data, so I'll call them as a string, and they are represented as str in Python. And then these things are known as the Boolean data. We call them as bool, B-O-O-L. So these are my data types. These are my data types, and this is particularly my data. Now these are the representations. So how we will represent, or maybe how this particular data is represented in Python. So this kind of data is known as integer data, for which we use int as the description, or maybe representation. Now the next point is how we process this data. Before we process this data, we need one more thing. Let's take a very simple example. Let's say if I have to prepare tea, so I have to prepare tea. What all components I need, what all raw material I need. So let's quickly write down the raw materials. I need the very first thing is tea leaves. I need maybe milk. I need sugar. I need water. I need let's say ginger. What else? Maybe you need a stove also. But the very important component that we need before we can even process this raw material is the container. So the very first thing that we need is the container. And that is what the necessity comes when you have to process this raw data. So if I have to process this raw data, I need a container. So if we have to process raw data, what I need? I need container. And these containers, or maybe the data containers that hold the data for processing, are known as the data objects. They are the data objects. So the data objects that we have are list, tuple, sets, string, dictionary. Now these are my data objects that we have in Python. A data object is nothing but a data container which holds the data for processing. As simple as this. Now we have understood three main important terms. Number one is the raw data that we have, followed by various data types and the data containers, or maybe the data objects. But you guys must be thinking that why we have so many data objects? Why not only one? Why we need so many containers? Now let's take a very general example. Let's say if I have to prepare, or maybe if I have to cook rice, will I be using the same tea container? If I have to prepare chapati, will I be using the same tea container? If I have to fry something, will I be using the same tea container? The answer is no, we will not be using it. So in our kitchen, for each specific item which we are looking to cook, we have a specific container. And the same idea goes with Python also. Here we have different type of data containers because each container is designed for a specific task and it comes with certain set of rules and regulations. So here each data object is designed for a specific task and comes with certain rules and regulations. So this is the concept of data objects. Now once we have understood what is my raw data, followed by what are the data types, followed by what are the data objects, let's try to now understand the term variable, because this is a most confusing term. So let's try to understand with an example. Let's say we have some containers. So this is my container number 1, another container with a different shape, and another container with a different shape. So we have 4 containers over here. Let's put some content into them. Container 1, container 2, container 3, and container 4. So each container over here is consisting of some kind of balls, and in order to make it different, I am just putting random number of balls. Now let's say we have a boy, or maybe a child, and you want this kid to bring out this container for you. Now how you will explain this particular kid to bring this container? Now this particular kid does not understand count, so you cannot say that bring a particular container which is having 5 balls, because this container and this container, both of them are having 5 balls. You cannot ask the boy to bring a container which is having combination of red and blue ball, because both the containers are having combination of red and blue ball. Now the very easy way to help this particular kid bring out one of the container is either you can number them or you can name them. So numbering and naming both are the same thing. So I will name them. I'll call this as A, this as B, this as C, and this as D. And that is what the concept of data objects are. A variable is nothing but a name given to a data object or a data item. So here this A, B, C, D, these are my names which we have given to these containers, right? So what is a variable? A variable is basically a name given to a data object or a data item. When I say data item, I basically means integer, float, string, boolean, that basically act as a reference, that act as a reference. So please remember that there is a difference between a data object and a variable. Data object is a container, it holds your data, while variable is just the name or a reference given to a data object or a data item, for example list, float, string, or boolean. So I hope you guys are now clear with the 4 major terms. What is my raw data? What are the various data types in Python? What are the various data objects, which are basically data containers in Python? And at last, what are the various variables? So now let's understand how to write a simple Python program. Now if you wanted to use Python, you have multiple ways. If you want to quickly start working with Python, you can use Google Collaboratory. Google Collaboratory is basically a product from Google, and if you wanted to access it, you can just Google Collaboratory, Google Colab Python, and this first link which says collab.research.google.com, you can use this to quickly start working with Python. So here in this session, I'll be using the same platform so that you guys do not need any kind of installation. We have another method also. You guys can also install Anaconda, which is the very best, or maybe I would say a very easiest way to start with Python when your objective is to use it for data science. So here we do not need to install anything. When we use Google Collaboratory, it is very fast. We do not have to make an installation. We do not have to download it. It is basically a cloud interface. We get a web interface which is connected with the cloud so that we can quickly start writing our code and processing our code. So how we can use it? You have to just go to collab.research.google.com and you have to make sure that you are connected with your Google account. So if you are using Gmail account, that basically means you can use this platform for free of cost. Once you get this kind of interface, just click on new notebook and it will launch a new notebook, which is basically the interface on which we can write our code. Now this is the interface that it looks like, but before we can start writing our code, we have to connect. So connect to the server so that it can connect to the Python server and we can start processing our code. So I'll click on connect and you can see over here it is allocating the resources, connecting to the server, and once it is connected, it will show you connected, and it is connected now. Now Let's first of all print very simple command which we always do in all the programming languages to print something. So let's print hello world, and if I want to execute this, I can either click on this play button, this will execute myself, or the shortcut key is shift enter to play this. Now you can see that the output is immediately displayed below the code cell itself. So this particular line, it is known as a code cell where we can input our code, where we can write our code. Now the next thing is, let's try to create variables. So a is equal to 12. Now here please remember one thing, that this equal to sign is known as assignment. So I'll keep on writing the text to basically note down every point. So is equal to means assignment. So here what we are trying to do, we are trying to assign the value 12 to the variable a. So here please remember, a is going to act as a variable which is going to refer to the value 12. And if I want to execute it, shift enter, and now if I check a, I'll just put a and execute it, you will get the value 12. If I check the data type, so we can just say type of a, that is integer, int. So the type is a inbuilt function in Python which helps you to find out the data type of a particular variable. It can help you with the data type of a variable or a data object also. Now let's assign, or let's create variable for other data types. So b is equal to 12.2. Again, here we are assigning the value 12.2 to the variable b. Execute it, check b, and type of b, that's float. Now we will create a variable c with a string. So let's say Sumit Shukla. Let's execute this, check c, and let's check the type of c, that's a string. Similarly, d is equal to true. Now here, as soon as I write true, please remember here, if I want to declare true as a Boolean object, we have to put it with a capital T. We cannot put it without the capital T. So if I put it like without capital T like this, it will not be considered as an object, it will be considered as a variable. And since we haven't assigned any value to this variable, you will get error. So name true is not defined because we haven't defined true yet. We have defined a, b, c. These are my variables which we have already defined, but we haven't defined true. So in order to make this as Boolean, I have to put capital T and execute it. And if I check the type of D, that's bool. So let's print all of them in one shot. A, B, C, and D. And you can see that all the values are getting printed: 12, 12.2, Sumit Shukla, and true. Now we have created the assignment operator. We have understood how we can assign a value to the variable. We use one more operator which is known as the equality operator. So if I use this is equal to sign for 2 times, this is equality. Now what is the meaning of this? Equality check. So if I say A, now you remember that A was 12. If I say A is equal to 12, now this becomes a equality check code where we are trying to check if the variable A consists of the value 12 or not. So if my variable a is holding the value 12 or not. Now since we already know that variable a is holding value 12, we'll get the output as true. But if I say a is equal to 13, we'll get the output as false because a is not holding value 13, it is holding value 12. Similarly, we have the not equal to operator. Now how we can define not equal to? We can say exclamatory mark equal to, that is not equal to, non-equality, equality check. So let's check it out. If I say a is not equal to 13, that's true because a is equal to 12. So this is how we can use the equality check operators to basically compare if a particular variable is holding a certain value or not. So we have understood about assignment, equality check, not equality check. We have declared some variables. Now let's do a quick mathematical operations. So here we are not going to cover everything, but we will be covering all the basics which you need to work with Pandas, because here the objective is to get you guys started with Pandas. So we are understanding the little bit of Python first of all, and then we will jump to Pandas. Now here we have understood that how we can assign a variable, how we can check the data type of a variable, how we can perform non-equality and equality check operators. Now let's do a little bit quick maths. So let's say I'm having two values, a is equal to 12, b is equal to 2, and here we have two variables a and b. If I say a plus b, I'll get 14. So this is addition. A minus b, that's subtraction. If I say a divided by b, a slash b is divided by b, that's 6. Here for division, we have a total of 3 operators. So let's quickly look into them. So I'll add a text. So the very first is a single slash, which is known as the float division. You will get the absolute float value. The second one is double slash. Now this one is known as the floor division. Floor division. And I'll tell you what is the meaning of floor division. And then we have the modulus operator, percentage, which returns you the remainder. When you divide a number with some another number, the number or maybe the remainder that you get is returned by this percent operator. So these are the 3 operators which we have for division. Let's create a variable a with value as 13, b as 2. Now if I say a divided by b, I'll get 6.5, right? Now if I say a slash b, here I will bring this float value towards the nearest lower integer. So if you assume a number line and 6.5 is over here, then the nearest lower integer is 6, and that is what this particular division is going to do. So this is float division. What it will do, it will bring down the float value to the lowest or the nearest integer down the line, not above the line, down the line, because it is floor. So I'll get the answer as 6. The next thing is percent operator. So if I say 6% 2, this will return you, percent b, this will return you 1, because when we divide 13 with 2, so 6 times 2 is 12. You will be left with a remainder of 1, and that is what is returned by this particular percent operator. So these are some division operators. Finally, we have multiplication. So if I say a star b, that's a multiplied by b. But if you want to take power, so a star b, that is a to the power of b. So here I'll say it is A multiplied with B, and here I say A to the power of B. Now we have understood the basics of Python, how to basically write a simple, how to declare variables, followed by how to do some mathematical operations. But we need few more details before we can start with Pandas. We need to understand what is indexing, we need to understand what is slicing, and also we need to understand how to write a simple for loop and also how to write conditions. So we'll cover up these four topics, and then we will jump to Pandas. So let's understand how to perform indexing and slicing. What exactly is indexing and slicing? Before we talk about this, let's quickly create a list. Now list in Python is declared using square brackets. So list can hold anything. We are not going into the details of how various data objects are created and what are the conditions to create a data object. Here we will try to understand indexing and slicing, and then we will try to understand the other operations followed by Pandas. So 1, 2, 3, 4, 2.3, 4.5, and Sumit, and then true. So this is my list, and let's create one more list which is the part of this outer list. So we have a list L. If I check the type of L, this is a list, and this list is having another list as the last element. Now list as a data object can hold anything into it, and each data point over here is represented as an element. Let me take you to my presentation to help you understand what is an index and everything in detail. So let's quickly create a list. 1, 2, 3, 4, 2.7, Sumit, and 1, 2, 3. Now here each element, so each data point over here is known as an element. So each data point in a list or in any data object is known as an element. So here how many elements we have? If you quickly count, it is 1, 2, 3, 4, 5, 6, 7, because this is one element. So a total of 7 elements are there in this list. Now there is a concept of what is known as index. Index is basically a virtual number given to each element of a particular data object. Now index is of two types or two kinds. One is known as the positive index. Second one is known as the negative index. So we have positive index, we have negative index. Your positive index starts from 0, go all the way up to n minus 1, where n is the number of elements. Your negative index starts from minus n, go all the way up to minus 1. So if I try to map my positive index, it will be 0, 1, 2, 3, 4, 5, 6, and my negative index minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. So this is the positive index, while this one is negative index. So we have positive index, negative index. Now if I want to fetch any element out of this particular list, there is a concept known as indexing. So indexing is basically the process of extracting one element out of any data object, out of a data object. So if I want to index, I'll just say L is square bracket I. Now please remember, these square brackets are used as operator to index or slice. So for indexing and slicing, and I'll be using these square brackets whenever I have to index and slice. This is universal in Python. So anywhere in Python, if you have the task of indexing or slicing, you will just use a square bracket. Now I here is basically the index number. So indexing, if I have to perform, I will first of all write down the variable name, followed by the square brackets, followed by, within that I need to declare the index number. Let's quickly take one example. If I say L of 0, I'll get the output as 1. If I say L of -1, I'll get the complete list because that's my last element. If I say L of -6, I'll get 2. So you can use positive index, negative index, that's not a problem. That's what is your indexing. Let's quickly understand slicing also. So let's create a list. 1, 2, 3, 4, Sumit, true, 7, 8, 9. Let's assign the positive and negative index. So 0, 1, 2, 3, 4, 5, 6. Then -7, -6, -5, -4, -3, -2, -1. One more easy method of assigning index is, for positive you can start from 0 and proceed from left to right. For negative index you can start from -1, proceed from right to left. That will easily help you to assign the index. Now slicing, what is slicing? Slicing is basically the process of extracting group of elements or more than one element out of the list or any data object. So if I have to perform slicing, I'll say L of, because L is my variable name, A colon B colon C, where A is your start index, B is your end index, and C is your step size. So remember we write, so let's say if I have to extract 3, 4 Sumit, I can simply write L of 2 colon 5 colon 1. Now why I have written 2 colon 5 colon 1? So let's try to understand this one. Here we have index number 2. So I'll start my extraction process from index number 2. I'll go all the way up to index number 5. But it is up to index number 5. So remember, this is up to. It is not including 5. It is not including B. It is up to B. And I'll extract every element at a frequency of 1 step. So 1 means frequency. At what step you will extract the element. So I'm saying one after the other. So you will get output as 3, 4 and Sumit. and this output will always be in a list because the initial data object is a list. So your slicing output will also be in a list. That is how we perform slicing. Now let's quickly understand indexing and slicing with an example in our Python interface, which is Google Colab. So here we already have list, and now let's see indexing. So if I say L of 0, we get the first element 1. If I say L of -1, we get the last element. If I say L of 0:5, which basically means start from the index number 0 element, L of 0:5, which basically means start from index number 0 element, go up to the element which is at index number 5 and extract at frequency of 1 step, because 1 is default, so even if you do not mention it, it is not a problem. If I extract it or if I run it, I am getting 1, 2, 3, 4, 2.3, because 1, 2, 3, 4, 2.3, this is index number 0, index number 1, index number 2, index number 3, index number 4. So up to 4 we have extracted everything. Now let's try to understand how to write a simple condition in Python. So in Python, conditions are declared using 3 clauses. The first one being if, followed by elif, followed by else. If, elif and else. How we do it? So let's say if I'm having a variable a is equal to 12, and I wanted to check whether this number is a even number or a odd number, and I wanted to print that. So I'll say if a%2 is equal to 0. I hope you guys now remember or maybe understand this code. So I'm saying if a%2, if I divide a with 2 and if the remainder is equivalent to 0, then, so for writing then we use semicolon, sorry, it is colon, print even, else, colon, print odd. And now you can see we are getting even. How to write maybe a conditional block which is having multiple conditions. So let's say I'm having a number 15. Now I have to check if the number is divisible by 3, I have to print div3 or div3. If the number is divisible by 5, I have to print div5. If it is divisible by both 3 and 5, I have to print div3, 5. So this is what I have to do. So let's say if a% 3 and a% 5 is equal to 0 and this also is equal to 0, then I need to print div3, 5. Now I have to write a conditional block which is else if. So in Python we use elif. Elif a% 3 is equal to 0, then print div3 and elif a% 5 is equal to 0, then print div5. Else I'll print a statement which says the number is neither divisible by 3 nor by 5. And let's try to execute it. We are getting div3, 5 because this number 15 is divisible by both 3 and 5. If I change the number to let's say 12, I'll get div3. If I change the number to let's say 10, I'll get div 5. If I change the number to, let's say, 7, I'll get the number is neither divisible by 3 nor by 5. This is how we can write simple conditional block. Now let's quickly understand how to write a loop. So we have already created a list L. Now let's say I have to iterate through this list. I have to iterate from one element to another element in this list. So in order to write a loop, I say for, then I in L, print I. Now this is a simple loop block. This is a simple code block to write a for loop. Now let's understand this. This is very simple. I am saying for, which basically means I wanted to write a for loop. I is a variable. Now this I can be anything. You can have I as, since we are talking about iterations, that's the reason we call it as I. But you can have J, K, L, M, your name, my name, anything. So I, and from where I'm getting this I? In L, which is L is my list data object. So I'm saying write a for loop where I'm taking the variable I from the list L and print I. And that is the reason you can see that we are able to print each of the element. This is how we can write a simple for loop. Now these were the topics, or maybe I would say we have not covered any topic in much detail, but I tried to give you a sense of, or maybe an overview of all the basic topics that you need to start with Pandas. So now let's start with Pandas to understand how we can manipulate data. Now Pandas is a library, and Pandas is basically the full form of Pandas is panel data, and there are multiple full forms. There is no correct full form what is the extension for Pandas, but Pandas is a core library for data manipulation and handling. So whatsoever you think of doing in Excel and whatsoever you wanted to do in Excel, like you wanted to filter the data, format the data, slice the data, maybe sort the data, apply pivot on the data. So everything that you can do in Excel is something which we can do in Pandas. But since Pandas is working on top of Python, it is really fast and optimized. So it works very easily with large data set. So now in order to start with Pandas, we have to first of all understand the concept of the data objects in Pandas. As we have learnt in Python, the base Python. For base Python, we have the data objects which are list, tuple, sets, string, and dictionary. Similarly, for Pandas, the data objects are number 1, series, and number 2, it's a data frame. Series and a data frame. Now these are the two data objects for the library Pandas. As you guys already know, if I want to process the data, I need a container. So these are the two containers in the Pandas library. Now let's say I'm having a CSV file and I wanted to process this CSV file or do some kind of data manipulation on top of this CSV file. So the very first step that I will follow is to load this file into a Pandas data frame. Pandas data frame, which is basically the data object for Pandas. So I'll get a result like this. And now I can perform any kind of data manipulation. So data manipulation and analysis. Now this is the reason we need the Pandas data frame, which is basically the data object for Pandas library. So for Pandas we have two data objects, series and data frame. What is the difference between them? A data frame is basically a data structure which comes with rows and columns. So we have multiple rows and we have multiple columns. So let's say this is my column number 1, column number 2, column number 3, column number 4, column 5, column 6, and this is row number 0, row number 1, row number 2, row number 3, and so on. These are known as your row index, and these are known as your column headers. And here we fill the data. Now this complete structure is known as a data frame. While each column of this data frame, is known as a series. So combination of multiple series creates your data frame. If I extract one column out of the data frame, it would be a series, but combination of multiple series. So this is series 1, series 2, series 3, series 4, series 5, series 6. So the combination of multiple series creates a data frame. So even if I'm having two series, S1, S2, and if I'm extracting two columns out of a data frame, it would be a data frame. If I extract a single column out of a data frame, it would be a series. So that is what a series and a data frame is. Now let's try to understand this complete logic, how to work with Pandas, what all basic operations we can do with Pandas, and how Pandas can make our life easy when it comes to processing huge amount of data in Python. Let's directly jump to Google Collaboratory. Now here we'll be trying to understand how we can do various operations with the Pandas library to analyze the data, to process the data. Title this as Pandas. The very first thing that I need is the data. Now you can either generate your data or you can get the data from the existing source. So I can get the data from a CSV file, from an Excel file, from a JSON file, from a HTML file. So there are multiple sources from where we can get the data, put it in the Pandas data frame, and then perform the analysis. Here, if we want to do any operations using the library Pandas, the very first thing that we have to do is to activate that library, or maybe call that library, because that library is by default not available to us as of now. So the easy way to do this is, in Python we write import. So I wanted to import the library Pandas as PD. I'm saying import the library Pandas as PD. Now PD is basically a keyword. It is like a variable, you can say. It's not exactly a variable, it is basically a keyword or a alias that I'm using for the library Pandas. So instead of using Pandas everywhere in my code, I will be using PD as a keyword to use any of the functionalities that comes within Pandas library. Now this keyword Pandas, or maybe this keyword PD, is not something which is compulsory to use. You can use AD, you can use DD, you can use SD, You can use your name, you can use my name, it is up to you. But since in the data science industry, since in the technology world, those people who are using Python, PD is a very popular word and it has become like a benchmark, or I would say it has become like a default keyword that everyone prefer to use. So I would suggest all of you to stick with PD so that even if somebody is trying to read your code, they can understand that you are trying to use a function from the library Pandas, because PD is a alias, a very popular alias for Pandas library. So let's run this. And you can see we have a green tick mark, which basically means we have successfully loaded the Pandas library. Now let's try to create a series. So I'll say pd dot series, and series with a capital S, and I'll pass a list to it, to this. So 1, 2, 3, 4. A series is a data object that you can see comes with a default index. So these are my row index. So this value is at row index 0, this value is at row index 1, and so on. Now if I preserve this to the value or the variable s1, and if I check the type of s1, it is Pandas core series, and finally you can read it is a series. Similarly, let's say I'm having a dictionary. Now we haven't talked about dictionary in detail, but dictionary is also a data object in Python, which consists of data in a key value pair format. So I'm having a dictionary which is having A and having values in list 1, 2, 3. Then I'm having B, capital B, and I'm having values in list 4, 5, 6. And then I'm having C, and then I'm having another list with 7, 8, 9. Now this is my dictionary, and I wanted to convert this dictionary into a data frame. I'll say pd dot data frame. Now please remember, in this function D is capital followed by F is also capital, and I'll pass my dictionary D. Now you'll see that this has been converted to a structure which is looking like an Excel file having rows and columns. So this is a data frame. I can preserve this in a variable, let's say df. df stands for data frame. And now if I check the type of df, it would be a Pandas core frame. It's a data frame. So we have understood how to create a series, we have understood how to create a data frame, but this is not how we are going to proceed. The process that we generally follow, or most of the time we are going to follow, is getting the data from some source and then processing it, or maybe loading it in Pandas data frame and then trying to do some manipulation on top of it. So that is what we are going to do in this particular video also. Let's first of all get the data. Now since we are using an interface which is running on cloud, I have to first of all upload the data in this cloud interface. So here in this particular video, we are using how to upload the data in this particular cloud interface, but we have another video also where I have explained everything regarding how to upload the data in using Excel files that you have in your local system also. So you can refer to that video also. In order to upload a file in this Google Colab platform, the very first thing you have to do is click on this file option. Then you will find out the upload to session storage. Click on this, and then you can navigate yourself to the location where you have the data. I have the data in the download folder, and this is the file which I was looking for, the train file, and I'll open it. It is basically asking us to ensure that this file is only available for one current session. So as soon as I close this file and I come back to this platform tomorrow, I would not find this file available to me. So I have to re-upload it. This is what this warning means. So I'll click OK, which I am very much okay with this process. And my file has been uploaded. Now I'll go to these three dots and I'll copy the path and I'll close this now. Now in order to load a file into a pandas data frame, I'll say df is equal to, df is nothing but a variable, pd dot read underscore csv, because this is a csv file. This file is a csv file. So I'm using read underscore csv. Now if I delete this, if I just write pd dot and you can see that I'm able to get all the functions which I can apply with PD. So there is read underscore CSV and we will have multiple other options. So let's write READ and then it will show me all the options which starts with read. So read clipboard, read CSV, read Excel, feather, FWF, GBQ, HDF, HTML, JSON, ORC, Parquet, Pickle, SAS, SPSS, SQL, SQL query, SQL table, Stata table, XML. These are all the sources from which I can get my data, put it in the pandas data frame, and then we can process it. As of now, my objective is to get the data from the CSV file. So I'll use read underscore CSV parentheses and I'll paste my location. So Control V. Now this is the location. Now please remember, since we are mentioning the location, it is needed to be in inverted commas. So I'll put inverted commas and I'll execute this. Now my code was successfully executed. Let's check the type of df. It is a data frame. Let's check the data frame df. Now here you can see that this is how the data looks like. We have some rows. There are a total of 891 rows, some columns, and this data is all about whether a passenger survived or not in a Titanic incident that happened. So this is a Titanic survival data. Now what are the various operations which we can do? So once you have uploaded your data, once you have the data frame created with your data that you wanted to process, analyze or manipulate, the very first thing is to inspect whether the data was correctly uploaded or not, whether the data is having all the rows and columns as expected or not. So we have to inspect. Now pandas provide us with some inspection tools. So the very first one is df.head. Now what this function do, it returns you the top n rows. By default the value of n is 5. You can read the description. It says return the first n rows. This function returns the first n row, and by default, so here you can see that it says int is equal to 5, which basically means by default the value of n is 5. So if I run this, I am getting the top 5 rows 0, 1, 2, 3, 4. Similarly, we have df.tail, and this particular function returns the bottom 5 rows, returns the last n rows. By default n is 5. So these are my bottom 5 rows. Then we have df.shape. Now shape is an attribute which basically means it returns you a value, but it will not take any value as an input. In df.tail I can provide this function with an input. So I can say 1. So it will return me the last row. Yeah, I can say 3. So it will return me the bottom 3 rows. But shape will only return you a tuple or maybe an output where you have the number of rows followed by the number of columns. So this data frame which we are trying to analyze, it is having 891 rows with 12 columns. Now we have one more function, which is df.columns. Please remember, this is not a function. This is an attribute. So here it returns all the column names. Now once we have inspected the data frame, the next operation is to find out or maybe to extract a particular column. So df.head, it returns me the top 5 rows. Now let's say I wanted to fetch out this column survived. So I'll say df, as you guys already know, we have learned about this previously, that if I have to perform indexing or slicing, we use square brackets. So I can say df is square bracket, then I'll mention the name of the column survived, and I'll execute it. Now you can see that a particular column is returned as a series. So if I check the type of this particular code, which is returning a series, this is a series. But if I try to extract 2 columns, so I'll say df square bracket. Now within this square bracket, since I have to extract more than 1 column, I have to provide this as a list of column names. So I'll say list, and within this list, I'll mention the column. Let's say I want the column survived and passenger class. Survived column, comma, P class. Now you can see that once we extracted more than 1 column, it got extracted as a data frame. So if I quickly check the data type, or maybe the type of this particular output, it is a data frame. So this is what the difference is between a series and a data frame. Series is basically the building block of a data frame. When you combine multiple series, you get a data frame. Now let's understand how we can perform basic mathematical operations on a column. Given the survived column, let's say I wanted to find out the number of customers who survived. Now since the data is having ones and 0, where 1 means the passenger survived and 0 means the passenger did not survive, I'll simply take the sum of this column. So wherever there is a 1, I'm going to add all the ones, and you will get the total number of ones. So I'll say dot sum. If you have to apply any operation on top of a column or maybe a data frame, we use dot and then the function. So dot sum. So we got 342. So these are the number of passengers who survived out of 891. So we can check the percentage also. 342 divided by 891. So this is returning me the ratio. I'll multiply this with 100. So I'll put this in brackets. You don't have to put it, but just to make sure that my code is nice and clean, multiply with this with 100. And you have the answer as 38.3. So out of all the passengers, only 38% passengers survived. Let's try to extract one more column. Let's say now I'm extracting the column as sex, which is gender. Let's run it. Now here you can see that we have males and females. If I wanted to count the number of males and females, we have multiple operations, like how we can group the data, how we can group and aggregate the data. But in this video, we are trying to keep everything very simple. So let's not talk about grouping, but we have a very simple function which can help you to do this. The function name is value count. And it will quickly return you the count of each category in descending order. So since males were more than females, we got the first row as male 577, female 314. So this is basically a series which is returned as an output. Now similarly, let's say I wanted to find out passenger class, how many passengers were traveling in each of the class. So we can simply say df p class dot value underscore count, and here we have the answer. So most of the passengers were traveling to the third class, followed by first and then followed by second. Now let's say I also want to find the maximum, find the minimum. So let's say given the fare column, I wanted to find the maximum fare, minimum fare, average fare. How we can do this? Quickly extract the fare column. Then for maximum max, similarly for minimum min, similarly for average we have mean, and finally if I wanted to find out standard deviation and any other metric, we have the functions for them also. So dot std for standard deviation. So these are the mathematical functions which you can apply. Let's say I wanted to find the count, the number of rows. So for count we have count count, and it will return me the total number. Now let's say I wanted to perform calculations using these outputs. So I wanted to find out average by manually writing the formula. So df fare dot sum, and then I divide this output with df fare dot count. So here this particular part is going to return me the total fare. This is going to return me the number of rows, and that is basically my average 32.204, and that's what we got over here also, right? So this is how we can combine multiple formulas to basically perform various mathematical operations. So this is what we have understood. Like these were the very basic operations that we can do with Pandas. In this particular video, we'll be talking about how we can connect various platforms with Python to fetch the data. Also, we'll be talking about various basic operations in Pandas, like adding a new column, how we can rename a column, and various other operations. Before we start this video, don't forget to subscribe to our Scalers YouTube channel. Let's understand how to get data from a CSV file into Pandas data frame. So first of all, what we will do, we will import the library pandas as pd, and if you want more details regarding the basic of pandas, we have already created a video on this, so you can refer to that video. Now what we have to do, we have to read the CSV file, and the function read underscore CSV takes input as the location of the file. As you guys can see, I have placed my CSV file, which is titanic.csv, in the same folder in which I am running my Jupyter notebook. Now, if you have the CSV file in the same folder where your Jupyter notebook is running, you don't need to provide the exact path. All you have to do is just write the name of the file with the extension, that is titanic.csv, and you are done. Okay, so that is not df.read_csv, that is pd.read_csv. because PD is the library pandas. So here you can see that we have the data. We will preserve this data in the variable df, which is data frame, and now we can check the head. But what if this particular file is not available in the same folder? So let me just quickly do one thing. I'll go to the same folder where I'm having my Titanic file, and then I will copy it somewhere else also. So over here in the folder scalar, I'm having this file. I'll copy this, and now I'll go to desktop and I'll paste it over here. Over here I'm having the Titanic file. Now how we can read this file into Pandas data frame? First of all, we need the location of this file. So I'll go to properties, and here you have the location. I'll copy this and I'll close this, and now we write pd dot read underscore csv, and we will paste this location. Together with this location, we also have to provide the file name with the extension. So titanic.csv. Now if I try to run this, I'll get error. Now this error is because of a very simple problem. The problem is, actually this is not the problem, this is one of the functionality of Pandas or maybe Python. In Python, if I say print Sumit/n Shukla, you will find out that due to this /n, the characters or maybe the string that is after this /n is getting printed in the next line. So this is basically the new line character, and that is what is happening over here. This slash character is considered as an special character in Python. So due to this, in this particular string where we have defined the path of the file, this slash character is not getting considered as separator but as a special character. So what we have to do, we have to make this string as raw string. If I want to make a particular string as raw string, I only have to put this R in front of the string. So once you put this R in front of a particular string, this string is now considered as a raw string, and all these special characters or maybe the special operators that you have in this string which act differently are now getting considered as characters only. And that is what we are going to do over here. I'll just put R and we are done. Another thing that you can do is you can make this slash as double slash. So I can add one more slash, and this will be finally done over here. Now what if I have to read the data from any other external source? Please remember, your pandas read underscore csv command takes input from your local system. Also, it can load the file from online repository also. So there is a online repository known as data.word, and here you will find out that you have, so the platform looks something like this. Basically it is an online repository which comes with a huge repository of open source data. But there is one limitation, that is you have to create your account, and once you have the account, then you can simply copy the link and paste it over here and use this data, whatsoever data you wanted to use from this platform, into this local system or maybe your local Python notebook. So I'll go to sign in and I'll quickly create one new account. Sign in with Google, and let's say Sumit Shukla. I'll continue, and now we are ready. I'll search for the Titanic data, and here we have the Titanic data. This is not the best one. So Titanic, I'll search for the one which is having the original Titanic data. This one looks nice. I'll click on download. I'll click on share URL, and here you will find out the URL that you can simply copy, paste it over here, and you are done. So here what is happening, my data is getting downloaded from this particular link, which is the online repository where we have kept the data, and df.head we have the data. Now let's try to understand how we can perform filter operation on a data frame. If I wanted to filter the data, the very first thing that we have to understand is how to first of all index a column. So as we have learned that if I have to index a column, I can say df square bracket and the name of the column. Let's say I'm using the column sex. So here I'm having the values male and female. Now if I say a is equal to 12, and if I say a is equal to 12, I'll get the boolean output true. Similarly, if I here say a is equal to male, then I'll be able to get a boolean series. Wherever I'm having male, I'll get a true, while wherever I'm having female, I'll get a false. Now I'll use this boolean series to filter my complete table or my complete data frame. So if you guys carefully observe, here I'm having, so this is my condition which will return me boolean series which is true false, and here we are using this boolean series to index my data frame df. If I execute this, you can see that we only have those rows where I'm having the sex as male. Similarly, if I have to apply multiple filters, now I'll quickly go to my presentation and I'll try to explain the normal formula or maybe the normal code structure. So let's say I'm having this kind of data frame where I'm having, let's say, passenger ID followed by sex and followed by the column, let's say, fare. This is my data that I'm having right now. Now this data frame is having values like male, female, male, female. Fare is like 10, 12, 15, 5. Now if I have to filter on one condition, it will be data frame square bracket condition. This is the general code block to write one filter. But if I have multiple filters or multiple conditions, multi-condition, then it will look something like this. df square bracket round bracket condition 1 and round bracket condition 2 and round bracket condition 3 and so on, and close the bracket. So if I have to declare and, we use one time ampersand. For or, we use the pipe operator. Let's say I have to filter this data frame df on male. So I'll just simply say df square bracket the condition df sex is equal to m. This is my condition. Now here in this particular code, these round brackets are optional. Even if I don't use them, that's not a problem. But for writing a filter with multiple conditions, square brackets are very compulsory. df square bracket condition 1 is, let's say I have to find out all females, so sex is equal to f, and here I need to use is equal to f, round bracket close, and second condition is df fair is, let's say, greater than 10. So here if you closely observe, I'll just use a different color. These round brackets are compulsory. That's one of the thing. And this is my condition 1. This is my condition number 2. And we have these outer brackets, that is for indexing my data frame df. So that is how we filter a particular data frame on multiple conditions. Let's quickly go back to our Jupyter notebook and let's see one demonstration. So let's say I want all the females with the fare greater than, let's say, $50. So df round brackets df sex is equal to female and df fare is greater than 50. Let's execute this. And here you can see we have the data. What if I want the count? I'll just simply say shape and you will get the number of rows and columns. And if you want the count, you have to first of all index one additional column. So let's say I index passenger ID. And now I'll say dot count. And here we are done. We have 87 such passengers. Now let's try to understand how to add or delete a particular column in the given data frame. So let's say I wanted to add a new column in such a way that wherever I'm having embarked, or let's take an easy example first of all. So I wanted to create a new column, let's say double price. This is the name of my new column, which is equal to the current fare multiplied by 2. That's how easy it is. We have the value, this particular operation, which is df fare into 2, will generate a series with new values. Over here you can see. Now we wanted to preserve this series in a new column which is named as double fare. And if I execute it, if I go back and check df.head, here we have the double fare. But what if I have a condition? What if I wanted to apply a condition and based on the condition I wanted to generate a new column? Now the method is to first of all create a function. Let's create a function that can take the input, which is the embarked, the category of embarked, and then based on the category it assigns a number. So let's first of all check how many categories are there in embarked. So df embarked dot value underscore counts. Here we have 3 categories S, C, Q. Now if I want to write a function, I'll say def, the function name is MEM. It will take X as the input and I'll write the condition if X is equal to S, then I want this function to return, let's say 1. Elif X is equal to C, then I want this function to return 2. Else I want this function to return let's say 1 or 0 or maybe 3. But there is one problem. We have to make sure that the embarked column is not having any missings. So let's quickly check that. And I believe that embarked column is having missing. Embark.isNA dot sum, and here we have 2 missings. So in order to make sure that for missings also we are not getting 3, let's write one additional elif statement. So elif x is equal to a, then write, sorry, it's q, not a, q, then return I want 3, else I want 0. Now I wanted to apply this function to the column embarked. So I'll take the column embarked and I'll say dot apply. So if I wanted to apply a function, the particular method is apply and then the function name em. And now here you can see we are getting 1, 2, 3. We wanted to preserve this in a new column. So df, let's say em binary or em category. And here we have the output. So let's check the data frame df.head. And now I should get the new column emc, which is over here. But if you wanted to use a lambda function, that is also great. If you do not wanted to use the def functionality, so how we can use that? Df embarked dot apply, and the way we write lambda function is lambda input x. I need the output 1 if x is equal to s. Then else I'll initiate another if block. I need 2 if x is equal to c. Else I'll initiate another if block. I need 3 if x is equal to q. Else I need 0. Let's run it. Again we are getting the same output. Let's preserve it. Maybe we have already preserved it, so no need to preserve it again. But I hope you guys are able to understand how to create a new column based on condition using defined function and using lambda function. Now let's come to the third point where we have to understand how to delete a column. If you wanted to delete a column, we may use the functionality known as drop, and the function drop can help you to drop both rows and columns. So let's quickly understand. df.drop. Now the drop function takes the input as index, which is the row number, columns, which is the column name, and you can also use it with axes. Let's see all the ways. First of all, we will try to delete a particular row. So I'll say df.drop index is equal to 3. So I'm saying drop the third row. Here you can see I'm having 0, I'm having 1, but I don't have 3. But remember one thing, this particular drop functionality will return you a new data frame with the particular operation applied. So if I go back and check my data frame df again, it will not be having the same operation. This operation has not been permanently applied to a particular data frame. So how to make sure that this is permanently applied? All you have to do is write in place is equal to true. And now if I check df.head, you will find out that the third row has been permanently dropped. Please make sure that these operations are irreversible. So once you have applied it, you will not be able to get your original data back. So make sure when you are using in place, you are using it when you are 100% sure about it. Now how to drop a column? df drop, instead of writing index, now I will write columns. And now I'll mention the name of the column. Let's say I want to drop this double price column. So double underscore price. So you will find out that the column double price has been dropped. But again, this is not a permanent operation. So in place is equal to true, and we are done. There is one more way in which you can use drop. If I say df.drop 1, now what is the meaning of this one? Is it a row or is it a column? In order to make sure that Pandas is able to understand that this particular input is a row index, I have to define the axis. So I'll go to Markdown and I'll just write down a note for you guys. Axis is equal to 1 means we are referring to columns, and axis is equal to 0 means we are referring to rows. So here I'll say that this is axis is equal to 0. So I'm saying to my Pandas function drop that drop row number 1, and how Pandas will be able to understand that this 1 is referring to row number 1, because I have written axis is equal to 0, which means row. Here you can see that I do not have row number 1. Similarly, if I wanted to drop a column, df.drop, I'll write the name of a particular column, let's say em underscore or -c, and then I'll say axis is equal to 1, because 1 means I'm interested in dropping a column. And here you can see that I do not have that particular column. I hope you guys are able to understand some basic operation with Pandas library. And here we are going to take example of MySQL database. But if you understand this process, you will be able to connect any kind of database with Python. Here we will be first of all connecting the SQL database, which is MySQL database, with Python, and then we will be loading the content of a table into Pandas data frame. So let's understand how we can do this. First of all, we need a particular library known as PyMySQL. PyMySQL. So let's install it. And the way we can install it using Jupyter Notebook is you have to put exclamatory mark, then write pip install and PyMySQL. Now you have to execute it, and this will take around 1 minute of your time, and it is done. So based on your system configuration and your internet speed, it will accordingly take time, but for me it has been done now. Now let's proceed with connecting a SQL database with Python. So here I have a open source server. Now this server is running on this particular host name, where the port is this and the credentials are guest, which is by username, and password is relational. So let's try to establish the connection. My connection, which is the connection variable, PyMySQL dot connect. I have to input the parameter which is host, and my host name is relational.fit.cvut.cz, followed by the username. So user. Now here my user is guest, followed by the password, and my password is relational. Password is relational. Now we have to mention the name of the database with which you wanted to work. This particular open source MySQL server is having a variety of database available for your practice. And out of all the database that is available to us, we are going to only uh, we are going to only work with this database which is named as employee. So let's mention the name of the database, which is db is equal to employee. And let's now execute this. So here there is some problem with, oh, we haven't imported PyMySQL. So we have just installed it. So let's import PyMySQL. And let's now run this. Now you can see that we are able to successfully create the connection with the MySQL database, which is this particular database. And now we wanted to write a query that can work on this particular database. So the way we do this is by creating a cursor. Now a cursor is nothing but a object that will help you to perform variety of operations, or maybe it is the interaction between your SQL query or maybe your requirement, and it will transfer your requirement to the SQL database with which you are working. So c.cursor, sorry, conn connection dot cursor, and this is the cursor that we have created. Now using this cursor I will pass my SQL query. So I want to first of all look into variety of tables that this particular database is having. So I'll say c dot execute, and I wanted to execute show tables, this particular query. If I execute this, you will find out that this is returning me the output as 6. Now what is the meaning of this 6? Please remember that whenever you execute a query, your output will be preserved in the variable c, which you have initiated over here in the line number 5. Now if you wanted to look into the output, you have to perform the iterations. You have to iterate through each element of this particular cursor. Please remember, this particular cursor is preserving your data in a form of nested tuples. So let's try to look into the output. For table underscore name in C, print table underscore name. And here you can see that we have various table names, and we have all these table names in a nested tuple. Now we wanted to, let's say, work with departments table. So I wanted to look into all the tables or maybe all the rows of the department. Again, we will create a SQL query. We will execute c.execute select a star from departments semicolon. I'll execute this. Now we have 9. So 9 means we have 9 rows. If I try to fetch all the rows, I'll say all rows is equal to c dot fetch all, and it will fetch all the details in a form of a tuple. Now this is your nested tuple. Now we can convert this into a data frame using pandas. Import pandas as pd, and df is equal to, or maybe let's call this as dep, department is equal to pd dot data frame and all rows. Now when we look into dep, this is the data frame, but it is not having columns, which is the column header. Let's assign the column header. dep dot columns is equal to, the first one is dep id, which is department id, followed by the department name. So dep underscore name, and dep, we are done. So this is how we can connect Python with a particular database, and using pandas we can manipulate or maybe we can perform any kind of analysis on the data which we can extract after running a cursor. Now let's try to understand how we can get the data from a Kaggle competition directly into our Google Drive so that we can use that data into Google Colab platform. Now It is a very simple process, and let's try to understand how this works out. So the very first thing that we will do is to create a new folder in the drive of the particular Google account with which you are working. So I'll create a new folder and I'll name this folder as scalar underscore Sumit underscore demo. Please try to make sure that you are not putting any spaces in the folder name, because it sometimes creates the problem. So let's create. And now I will navigate myself into this folder. Now the next thing that we have to do is to quickly go to Kaggle platform. And if you have already not logged in, log into this account. So I'll sign out and I'll quickly log in. So I'll say sign in. I'll say sign in with your Google account. And then we'll go to your profile. Then we will click on this account button, scroll down. You will find out an option which says create new API token. Click on this. And as soon as you click on this, it will download a JSON file. Now this is a unique JSON file. So for each user, for example, since I am the user of this particular account, or I am the owner of this particular account, for each unique Kaggle account, you will have a unique credentials which is preserved in this particular kaggle.json file. Now I'll go back to this Google Drive folder and I'll upload this file. So I'll drag and drop over here. Now the next thing is we will launch a collab notebook. So let's quickly go to Google Collaboratory. It is completely fine if your Google Collaboratory is not working in the same folder. You can put your Google Collaboratory anywhere in your drive. But since I wanted to make sure that all my content or all my material is in the same folder, I am basically placing my Google Collaboratory on the same folder itself. Let's rename this. I'll call this as scalar demo. And now, first of all, I need to mount. Basically, I need to connect this particular folder with this Google Colab. So I have to basically mount the drive. I'll go to this file option. Right now, I'm not connected to any runtime or maybe any server. So it is, you can see over here, it is connecting. Once it is connected, click on mount drive. It will ask your permission. So I'll say connect to Google Drive. I'll provide the permission. I'll say this account. So we will click allow because I want to connect this particular folder or maybe Google Drive with my Google Colab. So it is basically mounting, and once successfully mounted, you will find out that I'll get all the content of my drive over here. So let's refresh it. And here you can see drive folder. I'll expand it. I'll go to my drive and I'll go to the same folder which says scalar Sumit demo. So over here we have the folder, and here you can find out that I'm having the IPython notebook, which is the Google Colab file, and Kaggle.json file, which we have downloaded from the Kaggle platform, which is the my account page. Now I have to create a virtual environment, basically a environment on which I can use this particular credentials to create a secure connection between your Google Colab notebook and the Kaggle account. So how we do that? Let's see. I'll use the library OS, which is operating system, and these lines of code are common for all of you. Like, it is not unique for me. If you are trying it out at your end, you have to do the exact same thing. So let's complete the code. os.environment. I'll create the environment as Kaggle underscore config underscore dir, and over here I'll copy the path of this particular folder, place it over here. Now I'll execute it. So what we have done over here, we have created a virtual environment where we are trying to create a connection between the Kaggle platform and the Google Drive platform so that we can directly fetch the data from the Kaggle platform or the Kaggle competition into my Google Drive. Now the environment has been created. The next thing that we have to do is to change the present working directory. So right now my present working directory is /content. I have to change it. So I'll say %cd, which is change directory, and then I will again copy the path of this folder, paste it over here and execute this. Now my current working directory is changed to this particular folder. If you want to cross check, just write pwd, execute it, and you can see that the present working directory is scalar Sumit demo. Now what next we have to do? I'll go to the particular competition from which I wanted to get the data. Let's go to some random data. Here we have data sets, and let's try to use Bitcoin historical data. I'll go over here, copy API command, copy this. Now go to your Google Colab and put exclamatory mark and paste this particular API command, and now execute this. Now you can see that I was able to download the data. If I go to the same folder and let's quickly refresh this. Okay, you can see that we have a zip file named Bitcoin historical data. But right now the data is zipped and we cannot directly use it. So we have to unzip it. How we can do that? You do not have to download this file, unzip and then upload it. Using certain commands, you can do it keeping the file in the Google Drive itself. Let's do it. So we will use the command exclamatory mark unzip. Now I want to unzip all the files with the extension .zip. So I'll say /*.zip, and once they are unzipped, I wanted to remove them also. So I'll say and rm, which is remove all the files with the extension .zip. Let's run it. And here you can see that this file named Bitcoin historical data.zip has been unzipped to create the CSV file. Let's check out over here if we have the file or not. We have to wait a little bit. Let's refresh it. Here you can see that the file is now created, bit stamp USD. This is a CSV file. If I go to over here, here also we have CSV file. Let's copy the path of this file and let's import pandas. Import pandas as PD, then data frame is equal to pd.read_CSV, and we will paste this path. Now this seems like a very huge file, that's the reason it is taking time. And now let's check the head. So this is the head of the data frame. Let's check the shape of this file. And that is having a lot of rows actually. So you can see the size of this file. So this is how you can connect your Kaggle platform with your Google Drive to get the data into your Google Colab notebook. So I hope you guys are now clear with both the topics regarding how we can get the data from the Kaggle website or maybe Kaggle competition into your Google Drive, and also how we can connect a particular database with Python. So with this, we come to the end of this video. Like this video, share this video with your friends, and don't forget to hit the bell icon so that you never miss any update from us. I will see you in the next video.